Assalamu alaikum students. Today we will solve the MCQs of chapter 15 organic compounds. The first MCQ is vital force theory was presented for. Option A is composition of organic compound, B is origin of organic compound. Here option B is correct, okay? According to vital force theory, the organic compound were obtained from the living organisms, okay? Because according to this theory, the organic compound contain According to this theory, the living organism contains some supernatural forces called vital forces, and that's why this theory suggests that the organic compound can only be originated from the living organism. The chemist prepared the first organic compound synthetically was Wohler. Okay, Friedrich Wohler heated the ammonium cyanide, and in turn he made the urea, which was organic compound. Okay, so Friedrich Wohler proves that organic compound can be obtained from non-living or they can be synthesized in the laboratory. The modern definition of organic chemistry is based on the origin of organic compound. Okay, according to the modern definition of organic chemistry, the study of those carbon-containing compound that is obtained from living organism as well as synthesized in the laboratory. But the old definition was that organic compound are those compound which is obtained only from living organism. So this is the difference between the modern definition and the old definition. However, the composition, structure and the physical property of organic compounds are same in case of modern definition and old definition. Okay, the only difference come in the origin of organic compound. The precise definition of organic chemistry is the study of carbon-containing compound. This one is incorrect because in organic compounds, hydrogen and carbon are present, and also nitrogen, sulphur, halogen and other elements are also present. So we can say that organic chemistry is the study of hydrocarbon, carbon and hydrogen and their derivatives. So option C is correct. Look, they are not the pure hydrocarbons, okay? Because sometimes they contain nitrogen, sometimes they contain hydrogen, sulphur, halogen. That's why we say their derivatives. In organic compounds, carbon atoms bond together to form chains and rings. This property of carbon is called catenation. Okay, when carbon make bonds with each other in order to form chains and rings, this property is called catenation. Our daily use products are mainly organic. We use water, natural gas, polish, edible salt, drugs, cement, paint, paper and food. Which of the following are the organic compounds? Now look at the option A. Option A contains water. Okay, here water is inorganic. Option B contains salt. Salt is also inorganic. Okay, option C contains drugs, paints and polish. So option C is correct here because these three are organic in nature. Here cement, water and edible salt. Water and edible salt is inorganic. Option D also have inorganic, so that's why option C is correct. Which of the following organic compounds are obtained from the living organism? Now look at here, methane. Methane is obtained from natural gas, okay? And we know that methane is not obtained from living organism. Vitamins are obtained from living organism, okay? Option B is correct here. Benzene is obtained from coal tar, okay? So it is also not obtained from living organism, and asphalt means charcoal, okay? This one is also not obtained from living organism. Only vitamins are obtained from living organism. The largest number of organic compounds are found in coal, okay? Because on destructive distillation, coal contain 4 other components, which is coke, coal tar, ammoniacal liquor and coal gas. And in these 4 components, they also contain many organic compounds, okay? That's why the largest number of organic compounds are only found in coal. It is formed due to the decay of marine animals and vegetable organisms, example plants. These were buried underground in the interior of the earth. They found high temperature and pressure for airs. The substance thus produced gradually moved through the porous rock under the great pressure, and then it reached those areas under the earth where it was surrounded by non-porous rocks. Here it was collected as large reservoirs. This is the theoretical statement for the origin of petroleum, okay? Now keep this in your mind that petroleum, the sources of petroleum is mainly marine animals, okay, and plants. And also petroleum is found in the porous rocks. That's why it was the theoretical statement for the origin of petroleum. The type of coal containing high moisture content is lignite. Okay, lignite has high moisture content because it is the first compound formed in the coal formation process. Okay, so lignite has high moisture content. Most of the compounds obtained from plants are of medicinal value. Okay, option B is correct here. An organic compound is synthesized from non-living sources using the basic component needed for it is called total synthesis. Okay, when we use the basic component, then it is total synthesis, and when we use the intermediate component, then it is called partial synthesis. Beer and milk products are the product of biotechnology. Okay, they are obtained from bacterial action. Okay, that's why beer and milk product are the product of biotechnology. The milk products here means are example cheese, yogurts, etc. Okay, the most productive distillate of coal is coal tar. Okay, because upon fractional distillation, this coal tar gives organic compound like benzene, toluene, xylene, phenol, cresol, naphthalene, anthracene, etc. Okay, that's why this is the most productive distillate of coal. In Fischer-Tropsch process, the distillate of coal converted into petroleum is coal gas. Coal gas contains carbon monoxide and hydrogen gas. In Fischer-Tropsch process, this carbon monoxide and hydrogen gas is converted into water and alkane. So option B is correct here. In Bucky balls, the smallest molecule known contain 20 carbon atom. Option C is correct. Okay, the smallest contain 20 carbon atom, but the most common contains 60. Okay, the most common Bucky ball contains 60 carbon atom, but here option C is correct. All elements given below can be detected in an organic compound without using Lassaigne solution except. Now look, carbon, hydrogen and oxygen can be detected without using Lassaigne solution. Okay, but only option D, nitrogen, is detected by using the Lassaigne solution. Here option D is correct. Okay, Lassaigne solution is prepared by heating sodium metal plus organic compound. Option C is correct. Okay, look, the nitrogen, sulphur and the halogens cannot be detected directly in the organic compound. Okay, that's why we have to make the Lassaigne solution in which we react the sodium metal. Okay, sodium metal is electropositive in nature. Okay, and we know that the halogen, sulphur and the nitrogen, these elements are present in covalent bond. Okay, they are bonded in covalent in organic compound. So sodium metal convert this covalent bond into ionic bond. Okay, and that's why in these elements like nitrogen, sulphur and halogens is detected in the form of ions. Okay, when the sodium metal convert the covalent bond into ionic bond, so those elements can be detected in the form of ions. Here option C is correct. When lime water turns milky, it shows the presence of dash in the organic compound carbon. Okay, because we have to find the carbon in an organic compound. Okay, that's why when the lime water turns into milky, it shows that the carbon is present in the organic compound. Look, in order to detect the carbon in organic compound, we react the copper oxide with organic compound. Okay, then this copper oxide, when combined with organic compound, it gives carbon dioxide plus 2 copper. Okay, now look at here, this carbon dioxide when react with lime water, calcium hydroxide called lime water, it gives calcium carbonate plus water. This calcium carbonate is insoluble in water, that's why the water turns into milky. Okay, now look at here, this carbon dioxide has come from organic compound, and look at here, organic compound do not contain the carbon dioxide. Actually carbon comes from organic compound. Okay, this carbon comes from organic compound and the oxygen comes from this copper oxide, so it makes the carbon dioxide. Okay, so it means that it represents the presence of carbon in the organic compound because carbon has come from the organic compound. So option D is correct here. Which observation confirms the sulfur in the organic compound when Lassaigne solution is reacted with specific reagent? So black PPT confirms the presence of sulfur. Okay, now look at here, Prussian blue PPT confirms the presence of nitrogen. Okay, the deep yellow PPT confirms the presence of iodine. Okay, and this white PPT confirms the presence of chlorine. and black PPT confirms the presence of sulphur. Now look at here. In order to make the Lassaigne solution, first of all we react the organic compound with sodium. Okay. Now look at here. From organic compound, in case of sulphur, sulphur comes and it reacts with sodium, like sulphur -2 and 2 Na+. Okay. So it gives Na2S, sodium sulphide. After this we react the, look, this is Lassaigne solution. Okay, in case of sulphur. After this we react the sodium sulphide with sodium acetate. Okay, so this reaction gives H2S, hydrogen sulphide plus sodium, CH3COO, sodium acetate. Now after this we take this H2S when applied with lead acetate paper. Okay, like this is the lead acetate paper. Okay, after this what happens, a black color comes here. Okay, so it confirms the presence of sulphur. Instead of taking lead acetate paper, you can also take the lead acetate solution. Okay, when we react this with sodium hydrogen sulphide, so it will give black PPT in the solution. Okay, so it will confirm the presence of sulphur. Lassaigne solution is reacted with the reagent like HNO3 and AgNO3, nitric acid and silver nitrate to detect. Now we know that in order to detect the halogen in organic compound, we use the nitric acid and silver nitrates. Here option D is correct. Okay, because bromine is halogen. First of all, we react the nitric acid in order to convert the nitrogen in the form of hydrogen cyanide, and also in order to remove the sulfur in the form of hydrogen sulfide. Okay, that's why we use the nitric acid, and after the removal of nitrogen and sulfur, we react the Lassaigne solution. We add the silver nitrate in Lassaigne solution. So this silver nitrate solution form pale yellow precipitate in case of bromine, white precipitate in case of chlorine, and deep yellow precipitate in case of iodine. So here option D is correct. Oxygen is present in organic compound when, look at the option D, sum of percentage of carbon and percentage of hydrogen is smaller than 100. So we can say that oxygen is present in organic compound. Look at the option B. If the percentage of hydrogen and carbon is equal to 100%, then it means that this organic compound is only consists of carbon and hydrogen. Look at the C option. When the percentage is greater than 100%, then this one is impossible. Okay, the percentage of carbon and hydrogen cannot be greater than 100% in organic compound. Okay, now when the percentage is less than 100%, then it means that oxygen is present in the organic compound. Let's suppose we can say that carbon is 60% and hydrogen is present 30% in organic compound. Then we can say that this 30 and 60 will be equal to 90%. Okay, and so after this we can say that the 10% is present oxygen. Okay, so option D is correct. Which of the following compound is not aromatic? Look, toluene is aromatic, phenol is also aromatic, and naphthalene is also aromatic. Now look at here, option C is not aromatic. Look, this one is cyclohexadiene. Okay, and this one is not aromatic. There are three conditions for aromatic compound. The first is they must be cyclic. Okay, so they are cyclic. The second is they must be planar structure. Okay, they all are planar in structure. Okay, now the third condition is they must follow the Huckel's rule. Now this cyclohexadiene do not follow the Huckel's rule. Look, Huckel's rule says that a compound must have 4n+2 pi electron. Okay, now look at here, this n is equal to 1 in case of this. Okay, like number of ring is 1 plus 2, so it will give 4 ones are 4, 5, 6 pi electron. Okay, so look at here, this Huckel rule says that the pi electron must be 6. Okay, but look at here, the pi electron is 1, 2 and 3, 4. So it means that this cyclohexadiene do not follow the Huckel rules. That's why this is not aromatic in nature. Which of the following compound is not heterocyclic? Now what is heterocyclic? Heterocyclic is the compound in which a ring has different elements. Like taking the example of pyridine. Look, this is the structure for pyridine, okay? Here 5 carbon are present in ring, but 1 contain nitrogen, okay? 1 nitrogen is present here. It means that they are heterocyclic. The elements are different. Carbon and nitrogen is present, okay? Look, this one is thiophene, okay? Thiophene also contains sulphur, which means that this one is heterocyclic. Toluene and look, this one is toluene, okay? And the cycle contain only carbon atom. It means that this is homocyclic, okay? So option C is correct, okay? Which of the following compound is not heterocyclic? Toluene. Look at the furan. In furan, instead of sulfur, oxygen is present, okay? So furan is also heterocyclic. Ethers are the compound in which option A, halogen substitutes 1 or more hydrogen of a hydrocarbon, like this, okay? This one is halogen. So this one, option A, is not ether. This is alkyl halide, okay? Look at the B option. 2 alkyl or aryl group are bonded to the same oxygen atom, like this is aryl, or this one is alkyl. So ether is option B, okay? This one is called ether. 2 aryl or 2 alkyl group when bonded to same oxygen atom. This one is called ether. Look, in case of aryl, the ether is like this, okay? C, product is derivative of ammonia. This one is also incorrect, okay? Hydroxyl group of C double bond OH is replaced by OR. This one is also incorrect because this one represents the ester, okay? Organic compounds in which the carbonyl group is attached to hydrogen atom at the end of a carbon atom chains are called aldehydes, okay? Let's suppose this is carbon atom chain, okay? And this one is carbonyl group, okay? And this carbonyl group is attached to hydrogen. So this one represent aldehydes, okay? C double bond OH represent aldehyde. Option D is correct. The general formula for amides is R C double bond OH NH3. This one is amide, okay? And look, this one is amine and this one is amide. Option B is correct. The general formula for aldehyde, or we can say the functional group of aldehyde is, the functional group of aldehyde is, sorry, this one is not present, okay? This is the functional group of aldehydes. Look here, option D is correct, okay? This one is the functional group of alcohol. This one is for amine, and look, this one is for ether, okay? And this one is for aldehyde. The following is functional group of, look, carbonyl group is present, oxygen is present, okay? And look, alkyl group is present. This one is the functional group of ester, okay? Now look at here, the functional group of ether is ROR, okay? And carboxylic acid is C double bond OH. And ketone, you know, C double bond O, and R here, and R is here. And this one is for ester. Which one is trans-2-butene, okay? The trans-2-butene is the one in which there is 4 carbon atom, and on the second carbon double bond is present, okay? And the groups are on the different side. Now look at here, 1 2 3 4, but look, the double bond is present on carbon 1, so this one is not trans-2-butene. Look at here, 1 2 3 4, okay? Double bond is present on second number, but this one is not trans-2. Look at here, the groups are present on the same side. This one is the cis-2-butene, okay? Now look at this one, 1 2 3 4, on carbon number 2, double bonds are present, and look at here, the groups are on different sides, so this one option is correct, okay? This one is the trans-2-butene. Look at here, 1 2 3 4, but look, the double bond is present on carbon number 1, not the 2.